Got to give the people what they want. All right. We are about to talk about verifying inverses by composition, aka Mr. Tillis is very excited about this topic. He's so hyped. Maybe if you're in his class, you know already. I know because I have to deal with this guy every day. It's ridiculous. All right. Anyways, I'm going to get there. So, write these two down. And what I would like for you to do is actually look at these two functions and see, what do you notice about them? Well, you may notice that they look pretty familiar. They got the same type of numbers in here, and we're going to find out some more stuff. I'm guessing you might have some ideas, though. So, what I would like you to do is we are going to find f of g of x. We're going to compose those. Another way to write that is this, f of g of x. Remember this? And so this is basically where you take g of x and you put it in to f of x. All right, so that's what I'd like you to do right now. You've been testing on this. You've done this before. So all I want you to do is take g of x and put it inside of f of x. Cool. Hopefully you did that. Now here's how I'm going to do it. I'm going to take f of x first, actually, and I'm going to write 3. And in place of that x, I'm going to put a big parentheses, and then I'm going to write everything else. Okay? And now I'm going to take this g of x and put it inside there. So I'm going to say, okay, it's the square root of x plus 7 over 3. And then let me get rid of this so it doesn't mess me up. Okay. So hopefully your composition looked just like that. Now what I want you to do is, following the steps of GEMMA and using algebra, I'd like for you to simplify this as much as you can possibly simplify it. Now, you can't get an answer because it's not equal to anything, but you can put it in a simpler form. Why don't you take a shot at it? Hopefully you just paused and took a shot at trying to simplify it, and if you didn't, you did it correctly, you got a very nice, pretty little answer. But let me show you how it's done. And again, this is the first time we've done this, so if you didn't get it, don't be stressed out. Okay. So I'm going to follow GEMMA. I'm going to look at my grouping. So I'm looking in here. There is nothing that I can mathematically simplify inside of here. So I'm good with my grouping. Now I'm going to look at exponents. So I see the square root of something is being squared. Well, those are inverse operations. They undo each other. They basically cancel each other out. So if I take the square root of something and square it, they're basically canceling each other out. So what I'm going to say is, okay, well, this and this undo each other. They cancel each other out. So I'm left with 3 times x plus 7 over 3 minus 7. And again, there's still nothing else for me to simplify inside my grouping. There's nothing else with exponents for me to deal with, so now I'm going to look at my multiplying and dividing. Well, what I see is, I see x plus 7 being divided by 3, but x plus 7 is also being multiplied by 3, right? Here and here. Well, back to old school fractions, and just knowing that these are inverses, these things cancel out. This 3 and this 3 cancel each other out. So I'm ultimately left with just x plus 7 minus 7. We are getting somewhere. At this point, my parentheses are not necessary. So I can go ahead and get rid of these. There's nothing else to do here. And again, I have x and I have 7 being added to it, but then 7 being taken away. Again, inverse operations that cancel each other out. My final simplification is actually just x. Oops, sorry that I moved that screen around. It's coming back, don't worry. My final simplification is just x. That's pretty cool. Well, guess what that means? This means, excuse me. This means when you compose two functions and the result, and please write this down, simplifies to x. So when you just simplify to x, this means the functions are inverses. So this is actually another way that I can check for an inverse. I could take my inverse and put it into my original function, and if it simplifies to x, that means I did the inverse correctly. Okay? So let's try this again with a new function. Let me pull up my new function here. So let's see. So let's go example 2, and you're going to start to see some similarities, some commonalities. I'm going to give you the original function, which is f of x, and it equals 2 times x plus 5 squared. I want you right now to find me the inverse of f of x. Go ahead and do that. Right, you guys were on top of the game, so you paused and you did that because you're cool like that, and you should have got for an inverse x over 2 in the square root minus 5. If you were super specific, you gave me a plus or minus right there, okay? So now what I want to do is I want to verify that this inverse actually works and is actually correct. So I'm going to take this and I'm going to plug it in right there. All right, so let's see what happens. And notice, I think writing big and putting your parentheses are key here. Why don't you try it and try to simplify it first? Hopefully you did that, and let's see if you got it or where you got stuck. No cheating, though. Don't just like cross stuff out and be like, oh yeah, it's just left with x just because you crossed things out, but there is no mathematical reason why you did it. Okay, so let's see. We have 2. I'm starting with f of x. So we have 2 in parentheses. This is where x would have been plus 5, and that would be squared. Let me move this down a little bit. I don't know why I didn't give myself a little more space. There we go. Okay, and now I'm going to take this and plug it in right there, which you should be familiar with. Boom, boom. And I'm going to write x over 2 square root minus 5. And from here, I'm going to follow good old Gemma. Gemma never lets me down. All right, so I'm going to look at my grouping. Inside of this grouping, there's nothing for me to simplify. Okay? Inside of this grouping, there is something for me to simplify. Because at this point, this is the square root. This is the square root of x plus 2 minus 5, and then you add 5 to it. Again, we see these inverse operations. So these cancel each other out. So I'm left with 2 times square root of x over 2 squared. Grouping is done. So I'm looking at my exponents now. I see an exponent. So I see that this thing is getting squared. But notice, I have something squared, and I have a square root. So I'm taking a square root, and I'm squaring it. Those are inverse operations. They cancel each other out. Again, these things should be starting to look familiar. So squaring and this square root cancel each other out. So now I have 2 times x over 2. And again, now here I have x being divided by 2, but then that whole thing gets multiplied by 2, right? There's x divided. That's horrible. There's the x divided by 2, but then I turn back around and multiply it by 2 right here. So again, those cancel out. My final product is x, which means my inverse is verified. All right, so that's what all the fuss is about. It's a lot of algebraic manipulation using all the different rules that you know about the order of operations and inverse operations. And Mr. Tillis is hype. And so that's great. It's good when your math teachers are hype about stuff. I'm trying to get there. This is the first time I taught it. Hopefully, you guys will be super excited. And I'm like, oh, yeah, this is great. So anyways, that's what I got. It's getting posted right now. So make sure you're ready, and we'll have plenty of time to practice in class. Thanks, guys.